Hi, and welcome to this video on the hazards and uses of radiation. The words nuclear and radiation tend to strike fear into people's hearts, and when we think of the kinds of things that happened in Hiroshima, Nagasaki, Chernobyl and Fukushima, it's not difficult to see why. But nuclear radiation also has many useful applications in the modern world. Over the course of this video then, we'll be looking at the good, the bad and the ugly of nuclear radiation. When the body's exposed to ionizing radiation, the atoms that make up its cells, tissue and organs can become ionized, which can cause them to interact with one another in unpredictable ways. This can damage cells or kill them completely. When DNA damage occurs, it can also lead to cell mutations, and it's for this reason that radiation exposure can lead to cancer. The dose from an exposure to ionizing radiation tells us how harmful it's likely to be to our health. The unit of dose is the sievert. Though as 1 sievert is a very large dose for a human to receive, we normally work with the smaller unit of the millisievert. The average person in the UK receives a dose of around 2.7 millisieverts per year from all sources of background radiation. This table should give you a rough idea of the dose you might receive from doing a number of different things. A larger dose of 1000 millisieverts, or 1 sievert, will lead to radiation sickness, while doses of several sieverts or more are normally fatal. For your exam, you have to know about the medical uses of radioactivity in some detail, and we'll come to those shortly, but first, let's look at the technique of carbon dating. Carbon-14 decays to nitrogen-14 by beta emission, with a half-life of 5,700 years. All living things contain a tiny amount of carbon-14. When they die, they no longer take in any new carbon-14, and so the amount they contain begins to decrease. By measuring the amount of carbon-14 in a dead plant or animal, we can estimate its age. Let's take a closer look at how carbon dating works by using a quick example. As you can see, the rhino skull, which was discovered by a fossil hunter, contains 10 to the power of 13 carbon-14 atoms, and the skull of a living rhino of the same size contains 4 times 10 to the power of 13 carbon-14 atoms. Here, we need to estimate the age of the skull which was discovered by the fossil hunter, so let's give it a go. Because both skulls are the same size, we're estimating that when the old rhino died, its skull contained 4 times 10 to the power of 13 unstable carbon-14 atoms as well. After one half-life, this will have fallen to 2 times 10 to the 13, and after a second half-life, it'll have fallen to 1 times 10 to the power of 13. What that means is that the age of the fossil which was found will be equal to 2 half-lives of carbon-14, which is 2 times 5,700 years, which gives an answer of 11,400 years. On to medical uses now. In medicine, a tracer is a radioactive material which is attached to a chemical which is naturally absorbed by the part of the body which is being examined. As the radioactive atoms in the tracer decay, the radiation they emit can be detected outside the body. Technetium-99m is the most common medical tracer. It emits gamma rays which are easily detected outside the body. These gamma rays are relatively low in energy and don't do too much damage to the body on their way out, and it has a short half-life of 6 hours, which means that it emits lots of gamma rays while a scan is being performed, but decays quickly, which minimises the risk of unnecessary prolonged exposure to the patient and to those around them. Here, technetium-99m is being used to investigate this person's kidneys. The technetium is first injected into the bloodstream. The chemical which it's attached to builds up in the kidneys and is filtered through to the bladder. The gamma rays which the decaying technetium atoms emit are then detected outside the body, which allows for an image of the kidneys and bladder to be produced. We can see in this image that the right kidney appears a lot brighter than the left one. This shows us that there's a blockage in the right kidney, as the technetium there isn't passing effectively to the bladder. Radioactive substances are also very important tools for medical treatment. Iodine is naturally absorbed by the thyroid gland. Certain conditions and diseases of the thyroid, including overactive thyroid and thyroid cancer, can be treated through the use of a tablet which contains iodine-131. When this unstable isotope of iodine is absorbed into the bloodstream, it starts to build up in the thyroid. The beta particles it emits when it decays will go on to deposit energy within the thyroid, which will kill or damage cells, treating the patient. the iodine-131 within the patient will continue to emit radiation for some time after they've swallowed the tablet, however, which is why patients undergoing this treatment may have to be placed into quarantine within the hospital until the amount of radiation which they're emitting falls to a safe level. That brings us to the end of this video on the hazards and uses of radiation. Hopefully you feel that you've had your fill of radiation by now, without actually receiving too much radiation dose, of course. Thanks for watching, have a go at the practice questions, and good luck.